In this particular case, it all depends on what the starting point of your period or your cycle is going to be. So let me show you a few different possibilities, at least the ones that are visible here. Let's say I want to work with a positive sign. Well, a positive sign, I can find one here. It would look like this. That would be a positive sign, and it's shifted a long way to the right. So it's shifted 3 pi over 2. So it's shifted from here all the way there. Then we can also come up with a negative sign if you like that option. A negative sign would start here and end here and would go something like that. So you could do a negative sign and find the equation, and this one would shift just pi halves to the left. So the shifting is not as much as the other one. Or let's say that you want to go for a cosine. Let's say you want to sketch a positive cosine. So you have this option right here. That is a cosine. And this one is shifted in the negative direction minus 3 pi halves. Or let's say you want a negative cosine and you want to find that equation. So you could use this as your negative cosine, and it would be something like that. So I feel like using the negative sign for the sake of this example. So I'm going to start here. I'm going to pass through those points. And I'm going to go like this. Now, let's, what I usually do, I trap the entire cycle inside of a box. And I find the midline to see if we have any vertical shifting. Even though this one does not appear to have vertical shifting, I'm still going to highlight the midline. And the midline is if I have 2 units going this way, I also need to have 2 units going down. And the midline is going to be exactly in between. So wherever the midline ends up being, here it is 0, but let's say that the midline ends up at 1, that's going to be your vertical shift. But in this particular case, I'd like to use this version of the equation, which is A. I'm using sine, so sine, and then I'm going to have K. So I'm using the factored version of K because that way it is easier to write down the shifting. So minus B plus C. So the amplitude is 2. A equal, well, it would be, the amplitude would be positive 2, but the A value is minus 2 because of the reflection. Then my K, I'm going to figure out the K by doing 2 pi over K, and that has to be equal to the exact position of the end of the graph or the complete cycle. One common mistake would be to use this point right here. But if you notice, this one is starting here and ends up here. So it actually uses 1, 2, 3, 4, 5, 6, 7, 8. Covers eight spaces. But it starts shifted. What I can do to actually figure out the actual period is trying to replicate that number of spaces, but starting exactly next to the y-axis. So 1, 2, 3, 4, 5, 6, 7, 8. So the actual period has a measure of 4 pi. And I can solve for k. So I'm going to get 2 pi divided by 4 pi equals k. I'm going to cancel out the pi's, and I'm going to get k is equal to 1/2. So that's my k. And I'm not multiplying the k by the inside of the parentheses because that allows me to figure out the shifting and write the shifting quite easily. So I have, I'm going to start writing the values. Y is equal -2 sine. And I'm going to write the k out here. 1/2 times x. And I'm going to find out the shifting. So from the initial position to this position, it was shifted minus pi halves. It was shifted in the negative direction. So if b is equal to minus pi halves, I'm going to substitute it here. So it's going to be minus pi halves and then plus c. And because the midline is exactly at 0, I can write 0 or just omit that value altogether. Now, I like this version of the equation. I can move on and write it as -2 times the sine of 1/2 x plus pi over 2 and plus 0 or nothing at all. So the midline is at y equals 0. If the midline was at y equals 1, you would have plus 1. Now, you could multiply this and end up with the other version of the equation. I don't find that necessary, but it would look like 1/2 of x plus pi fourths. And that would be another way of writing this. But this, for me, I actually like this version better because it allows you to see the actual shifting. The shifting is pi over 2. And in this version, to find the shifting, you would have to solve for x. You would have to do this equals 0. So you would have 1/2 of x equals minus pi over 4. Then you would multiply and would end up with x is equal to minus 2 pi over 4 or minus pi halves. So in this version, the one before you multiply, you get the actual shifting right there.